Welcome, everybody, as we dive into 8.2 using statistical experiments. Make sure that you put your name, your first name, and your last name at the top of your paper. Make sure you put your period number because that's very important for us to understand where are you coming from. So we're going to be talking about theoretical and experimental probability. This should be what should happen in an probability experiment. So for example, if you have a six-sided die, you should get each number 1 out of 6 times. Now, experimental probability, what actually happens in a probability experiment. So basically, let's say you have some loaded dice and you roll the dice and you get 6 50% of the time. Well, that shouldn't happen. And if that's the case, there's a flaw in the system and we're going to try to figure it out. So let's continue. So the law of large numbers states as the sample size increases. So for example, going back to the idea of asking our high school, what should our mascot be? If we increase the sample size, so if we go from 50 to 400, the variation in our data set decreases. So for example, we should have a better idea of what our mascot should be if we ask more people. Let's go on. So a student tosses a fair 8-sided die 200 times and records the result. Find the theoretical and experimental probability of rolling an 8. All right, well, if it's an 8-sided die, we can roll, it'd be, the probability of rolling an 8 would equal 1 over 8. Or, give me a second, 12, let's try this out, 12.5%. So not even a quarter, 12.5%, so half of a quarter, or 12.5 out of 100 times. Let's go on. The experimental probability would be, well, let's go back. We understand that they threw it 200 times. So the probability of rolling an 8 will be, and we look and it looks like, hey, it's going to be 42 out of 200 times. Now we could simplify this and break it down, or we can just use our handy dandy tool of starts with a C, calculator to figure it out. So using our calculator, we were able to determine that this would be 21%. Now, if you're wondering, hey, could we have solved this using our head? Well, yeah. Out of 100, if we threw it 200 times, we just have to divide by 2. So if we divide 200 by 2, we get 100. If we divide 42 by 2, we get 21%. So looking at this, theoretically, hey, we threw an 8 more times than what it should have been. There might be something there. Let's go on. So let's talk about probability model and simulation. So a probability is a mathematical representation of a random event. It consists of the sample space and the probability of each outcome. So for example, if we were talking about rolling the die, well, let's say winning is rolling a 1 or rolling that 8. And how many 8s are there? 1 out of 8. And then how many numbers are not 8? in an 8-sided die? Well, it'd be 7 out of 8. So now a simulation will be the following. So a simulation uses a probability model to imitate a process or a situation so it can be studied. So we can use coins, dice, random number generations that can conduct these simulations of experiments if we can't use the experiment itself. All right, guys, let's go on. So designing and running a simulation. So sometimes, we have a couple steps. So promotions. A company that produces bottles of water runs a promotion in which 1 out of every 8 bottle cap wins the customer a free bottle of water. So now we're going to describe the probability model. So there are 2 outcomes. So let's write this out. There are 2 outcomes, 2 possible outcomes. Winning a free bottle of water and not winning a free bottle of water. Theoretically, so let's go down. Theoretical. So the theoretical probability of winning a free water bottle is going to be 1 out of 8. The theoretical probability of not winning a free water bottle is going to be 7 out of 8. What is the chances of you winning? Pretty low. In fact, we already learned it. It's 12.5%. Let's go on. So we can, define the trial for the situation and state the number of trials to be conducted. So for example, cards might work. We choose 1 through 8 like card. Well, we'd have to change the aces to 1, but that's fine. We could use cards. We wouldn't be able to use a single coin toss because there's not 8 different outcomes. Marbles? Yeah. If we have 7 blue and 1 green, what's the chance? And we run through the trials that way. Standard die? A standard die is 6. Now we would need the 8-sided die for it to work, but not the 6, so that won't work. A random number generator might work if we put it and say, hey, we're going to start at 1 and go to 8, randomly choose one of those numbers. A spinner would work if we made sure that it was an equal representation all the way around of 8 different choices, and it's 1 out of the 8, and so on and so on. All right, let's go on. Now, for the simulation, we'd probably want to, conduct a certain number of things. So, the number of trials, number of times we would do it, we could do it 100 times. That way it'd be easiest for us to figure out, hey, it's this out of 100 or this percent, per ciento, percent. So, minimum value we'd want is 1. And then the maximum value would be 8. So we can conduct these trials for the simulation to figure out, hey, is this good? Now we can analyze the results. We should get, theoretically, we should get around 12%, 12.5, remember, 12% of a winning result, or our winning result should be 12%. Now, the problem is we can't get 12.5% because you can't pick. For example, you can't get 12.5 times of a number. It's not possible. You can only get 12 or 13. All right, this last one. Step 5. evaluate the simulation. Sometimes people are going to say it's rigged. Well, it might be. For example, McDonald's. Remember when they're bringing it back, but the monopoly. There was a time when somebody had the monopoly, someone working at Monopoly, or no, McDonald's, took the monopoly pieces and he kept on winning and winning and winning and winning. And everybody else wasn't because he took the winning pieces. Well, in that case, you can definitely tell you're like, all right, you should win this many times out of a million or out of 1,000 times you get the monopoly pieces. But this guy skewed the data and now, yeah, it was rigged. So, if we don't see that, we're getting the data that we should be getting, well, there might be a problem. Well, if somebody's losing, and let's say they pick, 20 times, it's not necessarily bad that, they didn't win. So for example, if someone buys 20 balls but doesn't win, I mean, the percentages of losing is about 88%. So 88% of the time, you're not going to get a winning bottle. And so if you buy a low amount, of course you're going to be like, oh man, I should have won at least once. Well, not necessarily. Your sample size isn't big enough. Now, if you bought 100, and you didn't win then, well, then something's skewed because you should have won. You should have, won at least 12 or 13 times, and you won 0. All right, guys. Thank you for watching 8.2, and I'll catch you guys in class. Bye.